I would like to thank everyone for coming and listen to my talk, and also thank the Griffith Media team for inviting me. So today I'm going to talk about our project on AI for koala road crossing behavior monitoring. So, So the goal of our project is to monitor koala road crossing behaviors using AI-powered observation networks. So this project is funded by the Queensland Department of Environment and Sciences Community Sustainability Action Grants, Round 4, which focuses on koala applied research in southeast Queensland. So everyone probably know that over the past years, the wild koala population has been dropping very quickly. In particular, over the past 10 years, it has been estimated that the koala population in New South Wales and Queensland has dropped for about 50%. So there are a variety of reasons for this population loss, like the habitat loss, disease, dog attacks, and so on. In our project, we focus on the koala road fatalities. So we did an analysis from 1997 to 2018. An average of 356 koalas entered the care facilities each year in southeast Queensland only due to vehicle collision. Therefore, mitigating koala fatalities and injuries on the road is a major task for koala conservation. But this requires us to understand the koala road crossing behaviors, when and where they tend to cross the road, whether they have been using the facilities, for example, built by the Brisbane City Council effectively, and so on. So in order to understand these activities, we need to have effective ways to monitor koala activities. Right? So over the past years, a lot of technologies have been developed to serve for this purpose. These include, for example, GPS and VHF tracking koalas, which enables us to track the movement of koalas continuously. However, this technology is intrusive. We have to capture the koalas and put the koalas on in order to be able to detect them. And it will not be able to find new koalas like joeys and so on. And then recently, our drones have also been used to do koala population survey. This is a very effective technology that can cover a wide range of areas. But however, there are also shortcomings, like the drones cannot fly everywhere. And also we need license in order to operate them. Right? In our project, we are particularly interested in a technology called camera trap. So I don't know how many of you have worked with camera trap, but this is an example. Right? So yeah, nice to know. So such kind of camera trap has a motion sensor in front of it. So whenever something moves in front of it, it will be triggered to capture images and videos. So we can set whether we want to capture images and videos. We can also set the length of the videos we want to capture. We can set the time we want the cameras to operate. And then, traditionally, when these cameras are deployed in the wild, we need researchers or people to go to the cameras regularly in order to maintain them, in order to copy the data. And then once the data is copied back to the office or lab, then we need people to really inspect each of the videos and images, which is quite tedious and time-consuming task. So our idea, we think, why is it possible to develop a technology that to enable the whole process from data capture to data transfer to data storage to data analysis and reporting? Is it possible to make the whole process automated? So that motivated us to develop this system, which is powered by the latest progresses in artificial intelligence, in sensor networks, so that we can integrate all the available technology together to serve for this purpose. So here is an example on how our system works. We can mount these cameras in any location that we are interested in monitoring. the movement of animals or anything else in front of it will trigger the capture of images and videos. And then the images and videos will be sent through antenna, through the mobile network, by email to our Griffith mail server. And then we have a program to automatically grab these attachment images and videos to our local machine. And here we have the AI algorithm to analyze these images and videos. So to first detect whether there is an animal in the image or videos, and then to detect whether the animal is a koala, and then to detect which koala it is. Yeah. So far, we have already got the system developed already, which I have a demo that can be shown on my computer to show all the data that we captured in real time. And we also have this system run automatically every day to process the images and the videos, so we can generate a report at midnight to tell us what have been captured. In order to be able to train this AI system, we need to tell the AI what is a koala, or what is a kangaroo, or what is a bird, right? So they learn just like babies. In order to teach them, we need to have all these labeled data sets in order to train them. So where can we get a large amount of images, right, for koalas? Definitely in koala centers, in zoos, right? So that's why we worked with the local koala centers. For example, Daisy Hill Koala Center, introduced by Matthew Harding. And also we worked with the Mogul hospitals, we worked with Lone Pine and Dream World. And also we get help from many universities and organizations, for example, the Redland Koala Action Group. So they provided us with the opportunity to install cameras to capture the koala images and images of other animals. And they also provided us with images that people have captured. So after these images are captured, we are able to train our AI system. And then the next step is to deploy the whole system at locations where we are interested in monitoring, so that the whole system can work. So these are some example locations that we deploy the cameras. On the left-hand most is the Upper Park Creek in Redland City Council, managed by Redland City Council. And here is the Ilawina Street Animal Pass, managed by Brisbane City Council. This is the pass between the Griffith Nathan campus and the Mount Gravatt campus. And here is at Wellington Point, where it's an animal pass shared by both animal and pedestrians. So it's underneath the railway, which is managed by the Queensland Rail. So our camera can be mounted very conveniently on any local structures. So here we show some examples of mounted cameras. So you can see the cameras, some of them are associated with the solar panels, so which enable them to work during the day and prolong the working period. So for a camera like this, if it's not triggered crazily every day, it will work, the battery can support it to work for 2 months, but with a solar panel, it can work for 2 years. So we have one camera installed at Compton Road, the animal pass there, which has been working for 1.5 years without the need to replace any batteries. And then we receive images and videos from these cameras every day. So you can see that we mounted a sign there. It's a sign to tell the public what these cameras are used for. And also we have designed this QR code so people can scan the QR code and upload any animal images they have to help us to train the AI systems. We developed 2 apps to help us do data management. This is the first app, which is a dashboard showing at each location from each camera how many images have been captured so far, and when those images and videos were captured. So we have the time information, the battery information, the mobile signal information. The system allows us to know which camera needs to be maintained and how many data we have received from each camera. So if a camera has not sent anything for a long time, there must be something wrong. Right. One example is early this year in February or March when we had the flood. The camera at the Aprapa Creek started not to work. So we inspected the videos and we see the water comes closer to the camera, and then suddenly the camera disappeared. So we thought we lost the camera, but after 7 days, it started to work again and started to send the videos again. So which means these ones are really waterproof. Yeah. So, and then we have another app developed which allows us to select a location and select the camera and select the time so we can see the videos in real time. So once our system reports, okay, one koala has been identified by a particular camera at a particular location at a particular time, then we can go to this app and see whether it is the case. Right? So we have a much less amount of data to inspect than just reading through all the videos and images. So these are the species we targeted to recognize. We have koalas, we have people, kangaroo, possums, birds, dogs, and so on, foxes. But in reality, we can see a lot of koalas, we can see a lot of wallabies, and surprisingly, there are a lot of foxes coming out every night, and we can see a lot of birds and so on. So here are some examples of videos. So you can see the detection results of these videos. They were captured at the Daisy Hill Koala Center. Those top ones were captured during the day, and the bottom ones were captured at night. At night, the infrared camera started to work. So you can see these interesting two koalas work underneath the visitor's deck every night. So originally we thought it's just one koala doing it, but later we found it's two koalas doing it because we see in one video two koalas works one after another. And here are some examples of the video we checked in the wild. So these three videos were captured at the Compton Road, the animal pass. So this one was captured in August last year, then September, then October. We suspect it's the same koala because they were captured by the same camera. And also they look like very similar. But we can see that in the first two videos, the koalas were working normally, but then in this third video, it's crippled. Yeah, so it's injured. Yeah. And our cameras have captured many other animals as well. Like I said, foxes, and this possum. This one was very fun to watch because we've been seeing this mom and Joey for a long time. We can see this Joey grow from very small to bigger and bigger. Yeah, and wallabies, and then this is guana. Yeah, so. Yeah. So so far we have made the system to be open accessed by all our partners. So everyone who joined our project will be able to link to the Griffith system and use these two apps that we have developed. And also we generate report for them every day. For example, for Queensland Rail, we have been producing report for them every day, and we have deployed about 12 cameras along the railways in the Wellington Point area. So for our technology, we are quite open for collaborations. If anyone is interested in using this system, you can purchase some cameras, and then we can set them up so they can be linked to our system. And then we'll be able to help you to automatically process, analyze the videos and images captured, and automatically generate a report for you. Finally, I would like to thank the team members. So we have Douglas Curling and Guy Castley. They were from our Griffith School of Sciences and the Environment. So they were experts in koala research. We have Cass Dexter, who is now with the Redland City Council. She graduated from Griffith with specialized in koala conservation. Willen is our expert in wireless network. He helped to set up the whole system. Farstal and Owen, they were my students who developed the AI part of the system. Daniela is from our e-research support team. And we also have Rob, who is our partner from the industry, helping us setting up the cameras, doing maintenance. Yeah. And lastly, I'd like to thank our founder, DS, and all our partners and helpers enabled this project to happen. Yeah. Thank you very much.